This is a C++ project for EE304, final project. I did my C++ program based upon a calculator, a computer, known as the E6B. The E6B is a common device used by pilots. It does a number of functions. It converts. It'll figure out crosswinds, headwinds for you, determine speeds, times, distances, etc. Quite a few functions on it, and I wanted to program a few of those functions in a way that they could be used easily by anyone. For my code, I used a number of for loops, and also here a do while loop, and then quite a few different formulas for the different conversions. I'll go ahead and open up the program. Okay, so as you can see, when you open the program, it tells you what it does, and then it gives you options to choose from here. So I'll just go through some of the options. The first one, fuel burn endurance, a common thing. Obviously, when you're flying, you don't want to run out of gas. So this allows you to quickly calculate your fuel burn endurance. So whatever fuel you started off with, you would have recorded that down. Let's say we started off with 2,000 pounds. Well, when we finished our fuel check, let's say we finished with 1,500 pounds. And the fuel check went for, let's say, 23 minutes. It's going to give us results that we burned 500 pounds of fuel, the burn rate in pounds per hour, the fuel burnout time, and if we want to know a reserve time, it also gives that as well. Distance conversion, relatively straightforward. This one had another nested for loop in it. We're going to enter if we want to determine kilometers, statute miles, or not, or if we have, kilometers, statute miles, or nautical miles. So I'm selecting nautical miles. Let's say I want to figure out how much 46 nautical miles is in statute and kilometers. So I get my result, 85 kilometers, approximately 53 statute miles. The program keeps repeating each time, by the way. When you're done with one function, it'll ask you which function you want next, unless you were to hit 7, which we'll do at the end here. Okay, temperature conversion. Enter your temperature in degrees, and here, let's say we want 30. We've got 30 degrees Celsius. It's going to return both Fahrenheit and Celsius. If we start off with Celsius, obviously the critical number here is going to be the Fahrenheit. The other one can be disregarded. Flight time based upon ground speed. Okay, we have to use consistent numbers throughout this. We can't put in a speed of kilometers per hour and then enter the distance we have to travel in miles. You'd have to do those conversions first. So here we're going to keep everything. Let's say we're traveling at 90 knots. And distance we have to go 220 knots. And the time of arrival is listed here. In this case, 2.44 hours. Headwind and crosswind can be really useful. Sometimes you have a max crosswind component the aircraft can land at with, it's also nice to know how much headwind you have. So we'll enter some data in here. First we enter the runway heading. Let's say 230 degrees. Wind speed, we'll say 30 knots. Wind direction, let's say we have a relatively good crosswind. So 320. Well, I'll make it a little bit different so it's not perfectly 90 degrees off. 310. And then we're going to get our headwind is only a little over 5 knots, and our crosswind's pretty strong there at about 30 knots. Finally, pressure altitude to density altitude. Oop, I hit the wrong one here. I'll restart it. pressure altitude to density altitude. Okay, so we're just going to enter our pressure altitude in feet. This is a density altitude is pressure altitude adjusted for temperature, and it affects aircraft performance significantly. So let's say we're at 9,000 feet. And enter temperature in degrees Fahrenheit, we'll say we're 64 degrees. The hotter it is, the higher the density altitude is going to be. Okay, so then we get density altitude 11,494. And finally, when you're done using the program, you hit 7, and it completes the do while loop, and you can exit out.